Thank you so much for the welcome and good morning, everybody. Very, very excited to host this panel today and kickstart with an amazing event. And what a better day to start, like at the backdrop of India AI Summit coming up next week, right? And we are talking about AI and autonomy here. Very excited to talk to the panel and get their views about how we are shifting from automation, which is largely rule-based, to autonomy, where systems can actually start taking decisions themselves, right? And what that means for engineering roles, what that means for leadership, what does it mean for authority as well as accountability of the decisions that the system will eventually start taking, right? And then where do we bring in trust in all of this? So we'd love to kind of hear the thoughts of the panel there. Before we get started, I want to kind of come to the audience and do a quick pulse check to see if you already have any automation running in production today. If you could raise your hands. I see 1, 2, 3, 4, 5, 6. Okay, some hands are coming up slowly. On a side note, how many do you really trust in the middle of the night that this automation is working for you as you expect? And not really kind of going back and double checking the decision and the thing that they've done. And that's where I think we'll probably have our discussion today, where we're looking at what does automation and autonomy really means from a DevOps context, right? And probably would try to bring in Bhupendra. When you're designing a system, right, from an architecture perspective, what are the clear signals that a system is actually ready to move from automation to autonomy, right? And like, how do you kind of let go of the control there?
Yeah, that's a very insightful question. Thank you for that. So I would first start with that. I think you initially termed the automation and autonomy already, but I think we are in an era wherein we have seen multiples of shifts which has happened, right? Now we are talking about automation and autonomy, but we started from something which is manual. So that pragmatic shift has happened wherein from manual, we have come to an automated CI/CD deployments, code check-ins, building artifacts and things like that. Now in the world wherein we are in autonomy. So how I define autonomy is that automation does what you are asking it to, while autonomy does what is required for. And that's where I think the question lies, right? What are the architectural paradigms which needs to be seen? The first and foremost things which I feel, right, currently the automation is kind of a rule-based engine, right? You have given it set of steps and it executes them. While autonomy is a decision-driven thing. You are taking certain decisions based on various data points and things like that. I would like to cite an example, the work which we currently are doing in BHN. We were a highly automated company, right? Our CI/CD pipeline was automated. The builds were getting created. We were running artifacts and things like that. But when it used to come to the deployment part, that's where the manual process used to get kick in, that you have to create change requests, get them approved, wait for the change review board to sign them off, and then do it, right? With the service which we have developed, we call it CDAS, Continuous Deployment as a Service. What it does, right, that anytime an artifact is getting created, it is actually aiding to that decision. When I say decision, meaning it is checking your health scoreboards, like how is your system behaving, is there any possibility that I should not be doing any kind of deployments because maybe it's a Black Friday, maybe there is a window wherein you should not be deploying and things like that. It is also checking were there previous failures in your deployments, right? So it is taking those automated decisions, and based on that, it is figuring out whether I should go ahead with the deployment or not. And that is where, if your systems have matured to a stage wherein you have started taking decisions, but just not waiting for the steps which a human needs to pass through, I think that is the first thing I would consider that. The other thing is changing from a step-oriented architecture to a goal-oriented architecture, meaning you had set of steps, but now what autonomy is giving you is that I have a goal. My goal is, let's say, I want to deploy my system with full compliance, as I think most of you are here, right? Compliance is the key. So how do I make sure that I have certain goals, and based on that I am doing these deployments? If you have achieved that, at the same time, you should have that knowledge awareness that that anytime if I have done previous deployments and if there is any challenges or anything which has happened, you are taking that feedback loop into account. If that feedback has come into play, then I would consider that some of the systems have actually matured from an automated system to an autonomous system, and that's where I am.
Okay. That's very interesting, right? So how do you kind of move from step-by-step approach to actually a goal-oriented approach, right? And then obviously that makes a lot of shift in terms of how we're going to look at systems and architecture. Anita, coming to you, right? So I think we were talking about how you have largely been a very on-premise system, and now with like a lot of automation that you're talking about, and moving largely from a cloud infrastructure, bringing in agents, all of that, right? So how do you, from a customer-facing platform, right, how do your engineers experience this shift, right? How are you getting them ready to sort of adapt to that and make that shift happen?
Okay, thank you for the question. So on our side, if you look at AI is excellent when it comes to understanding the patterns. So, but then does it understand the business as well as the customer intent? The answer is a big no. It can correlate events, traces, metrics, build fantastic proactive analytics. I can take a classic example. So you have an event which is disk shortage, which is coming from the system. And then you have another event where your application is timed out. Now with AI, definitely it helps to correlate this pattern, build proactive analytics, and relate these two events saying, okay, the application timeout is due to the disk shortage, you see. It can also build proactive detection. It can raise alerts. It can also provide proactive resolutions and recommendations, but are we ready for those resolutions and recommendations in a high-stake production environment? And that is where our engineers take a step back, you see. But AI works wonders in some of the aspects on automation. I think our panelists just spoke about. It's more on the efficiency side. I think most of the companies are now investing on the efficiency aspect. Recently, I was in a workshop with one of our partners, and they are doing fantastic job on the efficiency side. May it be workflow management or the CI/CD pipelines in it. I think we have advanced quite a bit on these aspects, you see. So personally on Amadeus, there is a lot of things which you have given autonomy on the efficiency side of the programs. For example, the QA efficiencies, the developer experience, engineering efficiencies. I think these are the places where engineers are trusting the AI to take the autonomic steps. But when it comes to actual production grade or the mission critical applications deployment, I think we take a step back here, and we need the engineers to validate these decisions. So yes, in certain contexts, our engineers are now well equipped to take a decision on where we can really go end-to-end automation with autonomy, and where we really need to take a handle on our side, because this is eventually about trust, which comes after a period of time. Yeah.
Very well said. I think it's still handled with care phase right now, right? So Naresh, from your perspective, right, I'm sure you'll be working with a lot of large enterprise customers and at an enterprise scale, right? Why do you think, or how do you think it's important to define this distinction between automation and autonomy, right? And what could go wrong if those boundaries are not set, right?
So I think I look at it as a continuum in a way. And in fact, the way I look at automation or engineering maturity or even AI maturity in that context, right, is you typically would have, and any enterprise or any company of a decent size, right, would have started with point tools, task level automation. You have certain activities that you actually automate. And that's sort of the starting point, right? And from there, you actually start moving towards integrating things, which is when your platforms come into play, integrated solutions come into play. That sort of becomes the second step or the second level. And once you're on the platform economy, you have the ability to actually harness data. And once you have the ability to harness data, then insights, intelligence, all of that. So in some ways, you build the runway for, sort of the next step, right? Which is, you can look at those insights to actually then, bring cognition in some sense. And the fourth step in this continuum is what I call AI-led autonomous. So first level, second level, you're essentially doing automation, right? The way Anita sort of defined that. Efficiency is what your primary game is. And once you move to level 3, level 4, you are actually driving cognition, you're driving autonomy. And obviously lots can go wrong, right? Because I work with Fortune 2000 companies, right? A lot of their business processes are fairly complex in nature, and you can't let anything to chance. So even 99.9% is not good enough, right? So you have to be 100% sure what you're doing. So when we are actually driving autonomous workflows, we are ensuring that they are fail-safe, and more importantly, ensuring that there is some amount of human in the loop in terms of clearly defining policies where certain things AI is allowed to do and certain things AI is not allowed to do on its own, right? For example, in production for a critical system, I would not want AI to be able to go and deploy without somebody having oversight, right? So I think I look at this as a continuum, one, and second, sort of with the guardrails, right, is how you sort of proceed ahead.
So looks like I think we still have some reservations on like till when we can sort of leave AI to take over, and then that trust is still kind of that we're still building in, and that brings me to the next phase. We're talking about trust, right? So I think we have all read reports of AI agents or chatbots actually citing legal cases which were never there, audit reports that were never there, or citing rules that were never there, right? And people have to pay huge penalty, organizations have to pay huge penalty for that. But I'm assuming that we are not too far away from a time when we can start trusting these systems, where somebody will start sort of saying, okay, today we do 50%, move to 60%, 70%, 80%. It's probably a matter of time, right? So now in that case, Abhishek, to you, right? So we have an AI agent which is managing your code, looking at all the alerts in the middle of the night when everybody's sleeping. It detects an issue that has happened, automatically goes into the system, fixes that issue, release is done, and nobody gets to know, right? Now, is it a scary situation? Are we getting back to Terminator kind of situation? Or is it like what success would really define, right? Because there's obviously an industry which is trying to make that change happen.
Yeah, so I think this is going to be a bit of both, right? The first of all, if at 3 a.m. My pipeline gets going and it is going to push the changes to the production, I should be happy. But let's say if anything fails, my engineer should actually be knowing what is failing. Unless until there is a fundamental understanding in terms of how the code has been framed, what is the architecture about it, and every minute information about the production systems, possibly the team might not be, be able to fix it. So that is the scary part, because nowadays a lot of codes are coming directly from the cursor, and the other drawback that I've been seeing is whosoever is actually asking the prompt are not aware of the entirety of it, like what is it going to actually give me as an output. And the consequences of this can be seen, let's say, if you basically write a query, right? That query can basically be written in a very simpler form to get the output that you want. But let's say if you give it to the cursor might give you the output in a very sophisticated fashion, and which may not be needed, right? So this is having a, for example, if you have a big query and if you're scanning for TBs of data, of course the cost will go high. Likewise, so these are some of the scary parts, right? But on the other side of the world, right? I'm getting a lot of things done from an engineer using AI agent, and at times I'm not sure how practical this is for a lot of organization now, but agentic is coming, right? So how can we have different agents to do certain tasks? Possibly from where I come from a data engineering firm, and we do a lot of collection, processing, and presentation of the data. So for collections, we have the Firehose, the likes of AWS Firehose, etc. But when it comes to processing, all these agents come into play. And all these processing happens through a CI/CD pipeline. So the best part is I certainly let my engineers to be efficient because these pipelines are automated. And if anything that goes wrong in the pipeline, these agents are so intelligent to understand what are the dependencies that has actually broken, right? And it is fixing, but not at 100% of accuracy, right? So we have to, we have been in a process to actually move from a less improved version, which is as of now, to a more improved version. But as of now, it will certainly take some more time to reach to at least 80% plus of accuracy to be completely, autonomously give the task to the AI agent to actually fix the issues and let the code go to the production without any human intervention. But ultimately, it's going to be a collaborative effort. There should be human intervention at any given point in time in future, and this is what I see, right? It is going to be agentic AI plus human for sure. If it's all AI driven, then again, the accountability, etc., will be questioned. So, again, the accountability has to be a person who really cares about their job. AI don't care about its job, right? Thanks.
No, definitely it does not, but as I said, I think it's more about when and if than if, right? So, but from your perspective, right? So I think as we start preparing for, well, we are in a current situation, right? But when you look at, let's say, 6 months, a year, 2 years on the line, which we don't know what might happen, right? When ChatGPT came, nobody knew suddenly what happened, right? So, but let's say if we are in that situation and we need to start planning for the future, so what technical and governance guardrails you think would be required for autonomy to start taking over than automation today?
Yeah, very interesting question here. Definitely, we need a set of technical and governance guardrails before we get into this automation thing and start trusting the agent's anonymity. Now, from technical standpoint, what I think we need to have, we need to follow those principles which we follow for any software engineering processes. For instance, an AI agent needs to have a clear identity. It should be identifiable, and we need to assign them very limited permissions, or we need to follow the least privilege principle strictly here, so that these agents are confined to the sort of actions they can take. Now, apart from that, these agents also need to have policy checks in place, wherein whatever actions they are taken, based on the roles defined for those agents, these policies should clearly define and control the actions they can take. And if we think further beyond this point, every action that an agent takes should be very minutely monitored, logged, so that we can trace it whenever there is a need. So from technical standpoints, all these observability criteria need to be met very efficiently. And now if we move on to the governance aspect of it, the organizations who intend to use agentic AI or these agents, they need to have a clear-cut definition of the policies, that what are the actions which an agent can take, which they are permitted to take, and what are the actions where a human oversight is required, where the approval from the humans is required. So that policy needs to be clearly defined from the organization perspective. That's a kind of governance control we need to have in place. Besides, we also need to have some sort of, let's say, human override option, where in case we want to pause the process triggered by an agent, we should be able to do that immediately. So we need all those sort of controls to really start relying on agents and automation of DevOps. Thank you.
I think this is interesting, right? So when we start looking at agents, obviously one is the technical capability of them being able to do something. There are architectural and technical guardrails that we put. But what I also hear is there's an emotional element of trust that is involved, right? Anita, I'll probably put you on a spot here, right? That as you lead a large engineering team, how do you make your team emotionally sort of ready for this transition? Because it's not going to be easy as a leader, as a developer, to let go of that, the authority that they had on the code that they were writing, the results it could produce, to an autonomous agent now doing it on their behalf, and they have to just do an oversight of that.
Okay, trust comes with how we use the insights. You see, so trust cannot be mandated. We need to earn trust. So in that span, I would say AI also needs to earn trust. So having said that, I will take, so these three angles, which is for any engineer is non-negotiable. One is your explainability. AI should answer and show why instead of only what, you see. And I think we all spoke about observability. Any actions we take not only needs to be traceable, but we also need to be reversible. So we need to have that trust that, okay, any action we take, we can still reverse it. And of course, the guardrails, which we all spoke about, is about how much of autonomy should be providing for AI to execute a decision. So let me take an example here. I think we all come from industries where speed is quite critical aspect, automation everywhere, and we want to build self-serviceable platforms. So what it means for us on building the self-serviceable platform is we want to provision, configure, and deploy all at scale in high-grade production system, mission-critical applications, you see. So we can do in two different ways, either on imperative interface or a declarative interface. Now, when you take an imperative interface, you have a UI, you click a button, and your work is done. So this works very well when you are an operator and you're sitting and you find an issue and you want to fix the issue. I think this works very well. And here again, we still are dependent on operator or a human validation. And now comes the declarative side of the story. So we want to deploy all our applications in scale in production. Now, what do we want to do? We want to create a file or a blueprint which has all the configurations, the artifact tree, all the jobs and topics, and then we push it to the infrastructure. Now, it's up to the infrastructure to take this particular blueprint, try to find a delta, and create a single source of truth. So now this single source of truth should be in a position to either you upgrade the software vertically, the different versions, or you should take the single source of truth and be in a position to deploy in a new region from scratch. Are we ready for this kind of a single source of truth from giving autonomy to AI? Today, that's a lot of trust factor. That too in a mission critical space where speed matters, and then there is a tight SLA driven kind of an architecture. So for me, I think the engineers will gain trust like we all as engineers have gained trust over a period of year. I think AI also needs to gain trust, consistently performing and also taking accountability, I must say. So it's a long journey for us to move forward in that direction.
Absolutely fair ask, right? So then probably we could start small and see how they deliver on that. And with that, Vinay, right, so probably we'll just try to understand from managing large complex infrastructure cloud environment, right? So your engineers are obviously overloaded with the alerts. There's a big alert fatigue that they have. How do you think autonomy and agentic AI can help you give you the right signals and information and reduce the cognitive overload that the engineers go through? And can that be a success criteria for agents to work well?
Okay, yeah. So it's in modern cloud environments, it's not about the amount of data being generated in the form of alerts, but actually it's the intent behind those alerts and what the decision making is behind those alerts. So nowadays, when the alerts are reported, what DevOps engineers are occupied with doing the interpretation, correlation with the decisions, and identifying the impacts, and then based on that, taking the act upon it. So when we talk about the Agentic AI, it's not just about creating the new dashboard on which you can see the alerts, but rather acting upon doing the correlation of the alerts being reported and doing the business analysis, and based on that identifying the impacts and giving the proper heads up to the engineers so that they can act upon, or maybe they can assist based on that. So there are many things we can say that identification of the signals being reported from the infrastructure, the applications, or the business, from that the decision making being made, from the signal being reported, and based on that it is notified to the engineers. The reporting to the engineers about the alerts being reported, instead of doing that, rather suggesting them like what can be the best to resolve those, or even do the self-healing, which is actually very important when agentic AI is acting upon it. And sometimes like doing intent-based escalations. Not everything can be self-healed, because there are many critical aspects which might cause the impact over the business or any decisions, or there may be something critical in terms of breach of policies or the cost involvement. That is where actually it should be appropriately in notifying to the DevOps engineers or the leadership what may be the impact of those things and what should be the right decision which may be taken care of. By doing all those things, actually it is going to be having the faster process, doing the better enhancement over the business decisions, and also just not doing the tries where actually engineers are mostly involved, rather they can do the more productive work like doing the guardrails creation and also some of the decision makings in the system. Yeah.
Thanks, Vinay, for that. Abhishek, from a DevOps leader perspective, right? So how do you ensure that AI is freeing up time of your engineers to actually do value-added work? Is there something that you already started an initiative?
Surely, yeah. So I will take a few seconds to talk about the history. So back in 1990s, we had a transition that we have moved from mainframe to x86 machines. In early 2000s, we have seen virtualization, and by 2015, 2016, we have seen Dockers, and we have seen the craze, like, we used to put everything in Docker. And 2020, 2021, we have seen some advances in terms of automation, and 2023 we have seen artificial intelligence, and now 2024, 2025 we have seen agentic and whatnot. And now there is a concept called no-ops also. So which means no-ops is it's more inclined towards agentic to do strategic thinking in terms of what should be the next step, right? And but it needs a lot of data. So the most important thing with all the prompts that we usually do, and also that we work with AI, is documentation, right? So for the engineers, on one hand, AI is going to do the job for you. On the other hand, you have to make sure the documentation is up to the mark, right? Because what IAM roles, what secrets to be used, what not, right? Where you're going to keep it. I think there will be some contention from the SEC team as well in terms of what to be integrated with MCP, then tools and whatnot. All those things. So on one hand, certainly this is going to help the engineers to address the tasks which are, which are daily, which are done by something like the cron jobs in terms of the automation term. On the other hand, the fundamentals, again, I think I touched upon that in the previous question. So engineers will certainly be scrutinized in terms of the fundamentals, because AI can write the code, but what if things goes wrong? This is one aspect. Second aspect is the documentation. And third aspect is, how soon can you implement this to have ROI? That is something that I'd like to bring in, because what I've seen is having AI integration, AI ops, all these things are certainly very good, because LLMs can handle large data. It can scan through the logs. It can look at the monitoring tools, and it can give you the insight in terms of what could be wrong, right? Likewise, AWS has MCP server for K8s, which can be integrated with MCP, and you can have multiple tools to connect to, to external tools, right? And it's all open source, right? So again, identifying the issue, identifying the RCA, certainly all these things are going to help the engineers to come to the conclusion and come to a point like, okay, what should be the right approach to fix this problem? This is one. The other part is, if our engineers is so prompt in fixing those bugs, right, I think there will be certain ROI. But I mean, all these things are so convoluted all together that if we know the problem, I will take an example like, last week in my organization, we have got a ClickHouse machine, right? And it's a big server with six nodes, and it's handling petabytes of data. We all know that our query is joining to Doris cluster, it's joining to BigQuery, it's joining to S3 bucket, right? But how would I know like where the problem lies, right? Where is the actual latency coming in, right? I have used Cursor. It took me almost 1 day to train it. I gave all the information possible. And then it gave me the insight that it is basically my GCS bucket. ClickHouse is querying Parquet file in GCS bucket, and it is taking that much amount of time, right? And then I came to know possibly I need to either work for ClickHouse caching, and then I came to know that ClickHouse has its own caching. And then that caching was having a TTL off. As soon as it reaches up to 80%, it used to clear the cache. So what I did, we have just increased the RAM on that machine and let the cache threshold to go high, and those latency issues have dropped, right? So all these insights which was not possible earlier, because I have got all the logs, all the data, but all these logs, wherever our money was going, we were not making a proper insight out of it. But with the advance of this agentic AI, all these models, LLMs and all this debugging has become very smooth and to the point. But again, it depends upon the engineer to also check if that is true, if that is fundamentally true, to spend time and effort to actually pick that as a problem statement and work on that.
No, of course, I think we'll have to start leveraging the power of AI to kind of help us find issues that we were not able to find earlier. But Bhupendra, that brings me to the next question, right? Can AI really solve issues and reduce firefighting, or it will move it to a different layer while the issues still remain?
Yeah, that's a very interesting question, and I think we are living and breathing in this space in our organization as well, right? So from the firefighting standpoint, right, engineers here, right, any engineer would not like to do a firefighting. They would like to create systems like which are fire resistant, right? So the first and foremost things which the automation or autonomy has brought in is we have definitely reduced the process firefighting. So what I was taking an example of CDAS, which we have built, what used to happen that we used to have this manual approvals of change tickets. Individuals need to write a lot of data points just to take care of the compliance requirements and things like that, right? That has significantly reduced, right? Now 99 or 95% of the change tickets which we raise are fully autonomous in such a way that we don't need to do anything of that sort. And that actually increases our release cycle, which used to wait for 7 days to like few minutes to few hours. So that is definitely a firefighting which the individuals have reduced. There are other assistants which we have created which are helping finding issues faster in production, support use cases, like there are certain known patterns. So I know, right, most of the panelists are talking about that there should be a checks and balances, but if there are known patterns, then I think we all agree that for known patterns, there is no harm basically in using AI-based solutions. So we are also trying to do and make sure that the known patterns can be resolved, and I don't need to wake up at 2 a.m. to figure out, oh, something is broken and I really need to fix it. Those kind of things are definitely there. And sometimes it comes to the correlation aspects also. There are many tools, many observability tools which we are using. If a human needs to identify what is happening inside my Splunk, what is happening inside my Neuralink, Datadog or whatnot, to figure out the crux of the problem. Now with this multiple agents coming into play, they will be able to correlate things faster, and that is where I definitely feel that for developers and for DevOps per se, the strategic shift has done. But now whether it has reduced the problem, the answer may or may not be true at this point in time, because right now it is a shift from a process standpoint that your execution has become faster. But from observability aspects, from governance aspects, we have more challenges, because humans are defining policies to figure out when actually my deployment is successful. We are giving the criterias, when should I be able to take care of my known patterns. Let's say I just gave an auto scaling option that, okay, if something breaks or I see a surge of traffic, just auto scale my system. And if we have not put guardrails, right, and then it can go exponentially high. And if some bad actor has touched our systems and they are just blasting our systems, and you will end up basically giving a lot of cost. So that is where I think the firefighting is reduced at the process layer, but at the observability, the policies and things like that, that is where I think it has increased. So the answer is yes, it has reduced to an extent, to a level, but definitely has shifted to the next level.
That's interesting, right? I think you're the only one who is a little more generous in giving autonomy to agents at this point of time. And Satish, with that, I'll probably bring you in to understand, like, if you have to pick up a couple of workflows, if you have thought about it, right? Which DevOps workflows do you think one we talked about was from an observability perspective, right? But beyond that, is there anything else that you think is ready for AI to start taking and become more autonomous at this stage?
I think, the whole build, test, and deploy is more or less autonomous already, right? So I would rather use the development phases where you use the coding, automatic agents to develop test cases, really do the code reviews with functional and non-functional aspects. I think that is really a great value for the development teams, because developers tend to focus on functional aspects and they miss out the non-functional aspects. So that's an area where I would really put in agents to do that. And other area that I think is very important is really the SaaS, DAS scans, and really building and defining defects, and agents to really define defects and really integrate with the ALM tools. So there are already automation around that. And a lot of these NLA reports which are thrown out by these tools are pretty large. And that's where I think agents can really help to extract that serious critical defects and assign it directly to developers, right? So they can bring in some productivity over there. So these are some areas that I think we really can use agents in the short term. Yeah.
Oh, that's interesting, Satish. Thanks for that. But while we keep talking about agents and agentic AI, I think we are so used to thinking about everything and being in cloud, right, and being cloud native. But we forget that there's still a large chunk of probably infrastructure which is still running on legacy systems, right? And Aparam, if I can bring you in to understand, like, how do you see large legacy system kind of getting ready, or will they slow down this entire vision of self-driving and autonomy that we're all talking about up here?
Right. Let's first understand which systems we call as legacy systems. What I can think of is, let's say, some banks still using mainframes, which are quite robust. We might classify them as legacy. We might also classify old ERP systems as legacy. Or even, let's say, monolith applications might be considered legacy if they have been developed, let's say, a couple of decades back, and we have to still maintain them. Now, the problem here is that we are talking about using AI automation or agentic DevOps for handling these legacy systems. The underlying problem is these systems were never designed or defined for such kind of automations. There might be systems which still require manual deployments, which still require a proper ticketing process to go through. And I think if they do not expose the APIs which are required for automation, or there are limited APIs, still it's going to be a challenge for Agentic AI to actually fill that gap and address and really help in self-driving DevOps there. So these are the inherent challenges. Unless we modernize our legacy systems, we might not be able to leverage the latest tech.
So I hope the cloud providers are listening. Right, there's a big opportunity, obviously, they're working on, but just kind of looking at obviously, when we talk about any new initiative from an IT perspective, we all go back to the CFO, that we want to invest in new technology, right? And everybody wants new shiny tools that are out there in the market, right? Abhishek, coming to you, right? So when you're looking at all of these new workflows, new agents that are coming in, how do you, when you look at what workflows can actually deliver the business impact fastest? I don't know if you have done any assessment internally within your organizations to justify to a CFO. I have to run every single deal through a CFO to work on an ROI statement to get it done. But how do you see internally when you pitch it and get it done?
Yeah, that is true. I mean, without a ROI, just a blind investment doesn't make sense. It doesn't have any business impact. And we as not just a DevOps leader, but we also as business leader and business stakeholder, we need to make those decisions. So few strategy with the AI, what works for me, and I was able to define the ROI to my CFO was, so observability data, just to give you numbers, we are ingesting 100 TB of observability data per month. Imagine, and we talk about like the data is the new oil or new gold. So I mean that huge data, and what we are doing about the data, if we'll train our AI, definitely it will start making more sense to us. How are we consuming those data now? Maybe few dashboards somebody has created, maybe few alerting rules, but that has to be evolved because we are deploying very continuously. Like when in my company we are deploying twice a day, imagine. So that data need to be trained and fed to the AI, and AI has to make decisions. But okay, just a decision doesn't make sense, like how to define the ROI. So few of the things I have automated, we have automated with the AI, like the reporting, like my engineering team, they say, okay, they are building the software, but they are not focusing on the quality because they don't have the data. How they will say, how I will say, okay, in the production, your data or your service is not performing quite well, maybe in your laptop or maybe in the test environment is doing well. So with the data, which is the observability data, which is fed to the AI now, AI is generating daily reports for the developers, sending the data, hey, your last full day, the observability data of the service is this. It has so many errors, the APM, P90, P99 metrics, where it went well, on what time, what was the peak and all. Those all observability data it is sending to the developer. So they are now aware that in my production, this is what is happening, and they are fixing. So from the ROI perspective, it is reducing or improving the performance of my system, which is a customer success. The second, my SRE team, which was involving to creating those kind of report. For one services, it was taking almost a day for a SRE engineer to create that report and send it to somebody. That SRE guy, he's free now and working on more strategic initiatives. So one day SRE job for 1 week, it's a direct ROI. So this is what is happening. Next, what I'm trying to pitch to the CFO, and I think the AI will be doing it, and it is more capable of doing it, is automating the complete or taking over my complete CI/CD process. So if you deploy twice a day, imagine the impact in the business. Like one bad deployment can create lot of trouble in the production. It will directly impact the customers. Unhappy customer, impact to the business, definitely there is an ROI. What if AI can start deploying and creating a pipeline and deploying? After deployment, it can only assess based on some parameter which will be defined by me, and based on this, if there is some problem, it can also roll back. Definitely my uptime will be improved, the bunk density will improve, and I'll be having a happy customer. So AI need to do that. Definitely from the DevOps perspective, I need to create so many guardrails and governance and everything. But that's where I think the world will be going, and CI/CD will be taking over by the AI system. So yeah, that's few strategic, and that's how we calculate ROI and convince CFO. CFO is very happy because I earned money from them using the AI.
I wish I get you in every single deal that I run, right, and work closely to define that ROI. But I think when we talk about a lot of this workload shifting and AI taking it up, right, while we talked about trust as a one element, but trust also comes with accountability, right? Now we have designed the systems, we've brought in the agents, we have deployed all of that. How do you who drives accountability? So if you would want to share, like, in an AI-driven system, how do you set the accountability metrics?
That's a good question, actually. So we all know that AI supercharges DevOps now. So it's faster deployments, it has smart fixes, it is also scaling up very intelligently based on the load requirements. But the truth is, speed without accountability is a big risk. And if you talk about in the scale. So we, as DevOps, basically cannot bolt this accountability to the further down the lane. Rather, we need to be very shift left towards yearly in the development cycle. So I would rather say that we should maybe 2 or 3 major parameters we definitely look into. The first one might be the shift left with traceability. If something is not traceable means we cannot trust it. So like how we do the versioning of our code, similarly we need to do the versioning of data, its model, decisions, so that if something, maybe AI is having some cost ramped or something hiked up, then we need to really trace back what is the cause behind it. So I'd rather say that audit trail should be not a speed breaker, but rather than it should also help us to bring the confidence on our AI systems. The second one, I would rather focus on human loop gated methodology. Basically, we know AI is very smart, AI can do a lot of things, but when we have the high risk activity, let's say we are doing some kind of a configuration script generation or deployment script generation, which might have impact to direct our business. So let our CI/CD pipeline should able to pause a bit, do the smart review on it, and then we can have that kind of accountability to make. So you can consider accountability just like our seat belt. It may not be the hamper the speed, rather than the seat belt. If something goes wrong, at least somebody is there as accountability. Normally in a war, what happens that machine never make war win for us. Basically the accountability, the responsibility makes our normally war wins. Okay. So similarly, we should think how it can be more of a accountability in that matter. The third one is to make them accountable or to support the accountability, we need a very good automated monitoring or drift detection system, because AI means drift definitely must be there. That will be there always, because sometime by scripts, environment changes. At least this real-time monitoring system, the observability monitoring system will definitely help to take some kind of a decision to the accountable person. Okay. And in that way, we can help the accountability part. So next is the policy as governance. So basically, whatever we are trying to do as a policy, as a code, so let it codify all them. Let security scan or the confidence test or whatever we are running, let it run on the parallel to our CI/CD lab, so that the output, whenever we will get it, at least we'll make sure that the security scans are completed. The confidence only, it will bring a lot to us. So I would rather say that accountability is very, very important. And in DevOps point of view, it should not be a brake pedal, rather than it should be more of a steering wheel, which will help us to direct in a correct way to get the most out of it from the AI point of view. So if you build such a system with this way of mentality, they definitely innovation will make the more speed, but accountability also get increases. So I would rather say that don't go always making how the CI/CD pipeline should be faster, rather than how we can build a more trustworthy pipelines that is very, very important from the scaling point of view. Thank you.
That's interesting that we are at how do we bring in accountability there. Now, Naresh, you talked about working with some of the large Fortune 2000 companies, right? At that scale, there's a lot of distributed workload that is there, a lot of companies deploying multiple models. How can you kind of scale that at the level of running large enterprise and still bring accountability in that process?
Yeah, so I mean, this cannot happen without platformizing, right? So I mean, that was one of the first things that we had to do. And back in the day, actually, we had to create our own platform. And in some sense, right, we have embedded a lot of these principles, guardrails, responsible by design sort of framework within the platform. So a lot of the heavy lifting actually happens through the platform. But if I were to sort of abstract the thought process, first and foremost, we have to understand that the human is always going to be accountable. I mean, you know, the code is generated by Copilot or whatever, right? But the code is under my name. So I am accountable. I can't point a finger at Copilot saying, you know, I don't know what's happening, and, you know, Copilot generated this code. So we have not yet got to that stage, right? The accountability still is with the humans. So it is very important that you establish this in terms of your policies and procedures within the company as to where the accountability lies and which personas, which persons are accountable. Second important thing is for you to scale, the ability to actually make sure that the maker-checker concept is in play. And again, something that you could do through the platforms is very critical. Somebody makes stuff, somebody checks that stuff. It cannot be the same team or the same person, right? I cannot self-certify stuff, right, beyond a point. So your zero trust principles have to come into play. Trust but verify, trust but validate, right? So again, platformizing helps do this at scale. The third important thing is metrics. For all your AI models in the back, do you have the ability to actually look at hard metrics in terms of efficacy of how these are behaving? The fourth thing we have done is within the platform again, build simulations. For example, if the AI is taking a certain path, it takes left instead of the right, the simulation will actually do both left and right. And therefore, at a later point, you have the ability to compare. The AI model actually took a left on the path, and the simulation shows the ability to actually then compare what would have happened if it had taken a right, and actually it has taken a left. You feed it into the training ecosystem. The model becomes better. So I would say, I think these 4 or 5 things, if we actually do well on the back of a platform, it would help sort of, you know, make sure that you can scale in a big way.
So unfortunately, accountability still lies with the developers, right? So they can't skip that, right? Now, when you're talking about, I think, obviously, this is going to bring in a big shift in terms of how the engineering teams operate, right? How the DevOps teams operate, and I would like to kind of get the panel's thoughts on the future of the DevOps role, right? Will that still be doing the coding? Will it become more strategic in nature? And Abhishek, right, to understand from your perspective, right, so do you see Agentic AI for the DevOps to use, can that become more strategic for them? Can their role become more strategic? Or they will have to continuously just sit there, monitor every single line of code that is being written, and then still do that job that they're doing today?
Yeah, obviously, I mean, there is no doubt about it that DevOps role will become more strategic. Not just the DevOps, but the whole engineering role, even development. Actually, I have written a book on it, DevOps-driven development journey to NoOps, where I have detailed about each and everything, how the future will be with the AI coming into the play. But talking about what AI can take over and how the DevOps future would be is like, as I spoke about, my observability data is now being fed to the AI, and AI for now, and we have a lot of trust issue with the AI, but to be honest. So it's only doing the read and analytics part. It's not doing the right thing. Any changes in the system is what we are not trusting AI with. But I think in the future, AI will start making those decisions and start doing the writing part as well into our system. For example, the CI/CD example what I have given, which I think it will be taken over by the AI. Incident management will be taken over by the AI. So while AI start doing lot of things which still kind of looks like manual, it's not that manual. I mean, there are a lot of decision making involved, but it will take over. Then what the DevOps team or DevOps role will evolve into is more strategic, where they will start thinking about system instead of the tool and the only part of the system. For example, how the complete observability data, the traces, the monitoring, and metrics with the cost and the CI/CD process are all clubbed into it, and how can I deliver my KPIs? My KPIs are maybe faster feature delivery, or bug density, or mean MTTR, MTTD should be reduced. I'll start more thinking about the error budgeting. Or maybe I'll start, or the DevOps will start developing the governance around the AI. I mean, who is going to take care of the AI? How the system will be getting upgraded? The guardrails around the AI, the governments, the policy as a code, and then start deriving the business metrics instead of just doing one particular thing. For example, me as a DevOps engineer, right now, if I'm saying, I will create a pipeline for your system. From there, I will evolve into, hey, I will productionize your system. So that's a completely strategic shift, which I think is going to happen when the no-ops will come with the help of the AI, and AI is going to take over many of the manual things, which SRE, not DevOps. DevOps essentially still is a culture. It is not some team. I believe it is not. But when we evolve, when we started having so many things, DevOps is breaking down into so many systems. SRE, even business continuity engineering, so many people call it. So whatever. But as DevOps is a culture, it will evolve as a culture. It will be more strategic. Everything else will be taken over by the AI, is what I believe.
Thanks, Abhishek. Just kind of building onto that, right? So as we start looking at the future, and Vinay, bringing you in, right? So as the cloud systems evolve, right, and become more autonomous, will the DevOps role move towards just designing policy and become an observer, or like, and would they lose like control on what they're building today?
Yeah, so role of DevOps engineer is not going to be diminished, it's going to be evolved. Reason is obvious. Whenever we talk about autonomy as Agentic AIs and all, they are not going to become pilot. They will still remain co-pilot. Even many products are having the term co-pilot in it. So they are assisting, they are helping us in doing many business decisions and solving the problems. But still, the result and the accountability for any solution still remains with the human being. So saying that whenever there are such autonomy tools are there, they are assisting us, that time the role of any human being will be evolved, and they will be doing rather even more bigger work, saying rather just doing the tries of the alerts and the incidences. They are focusing on making the policies which can help the autonomy to take care of doing the proper solution investigation and preparing the auto-healing. Running the script, running the script instead of doing, they are focusing on preparing the guardrails which can prevent the autonomy to do some tasks which might cause the things out of control. Then from moving from the reactive approach to the preventive approach, by assisting the Agentic AI, by preparing various kind of assessment which can be run by the autonomy time to time to make sure that system is always there in the preventive mode, rather getting into issues which can become the situation where human has to be involved in solving those things. So I would say here, the problem is not that things are getting autonomy, but the problem is that when you will not you will not be able to manage those intelligence system. So this is where human roles will still be evolved as a DevOps engineer for those things. Thank you.
Well, that brings a very interesting point, and probably the last question for the panel today, right? So as we're looking at, and Satish probably bring you in for this, right? So I think we're talking about there's a lot of role shift that will happen. The accountability, the expertise that is required to manage future of DevOps. Do you think the workforce today will automatically elevate to take up this role, or they're not prepared and they need to kind of acquire a new skill set to kind of handle the change that's going to come in?
Yeah, I think there will be a need for the DevOps professionals to really upgrade, right? Basically, they have to definitely be aware of agentic frameworks, agentic workflows especially, and also the MCP protocols and similar protocols, because all the tools they probably would use later on in the future would be already equipped with these protocols, and they have to definitely integrate them in their workflows, right? So one would be really getting the skills. I don't think it will become obsolete as such, the role, but they'll also move to governance, because as probably the AI moves towards the AGI, then a lot of decisions also will be taken by the internally within the within the workflow. So I think they are still a relevant role and would require skilling, which is definitely everybody's skilling up. So why not DevOps guys? So thank you.
Perfect, thanks. Do we have time for audience questions? Okay. Probably we can take a couple of questions if there are any in the audience. Can you direct to the audience?
So nowadays, yeah, hi everyone. Girish here. I am from Great Learning. So nowadays, we are writing lot of code. So code generation is not a problem. And main problem is the review. And review also we are using the AI tools are there. But that is again not accountability. So in the pace, because earlier we used to get months of time to deliver a feature. Now we are getting weeks and days of time. So how to basically maintain the quality and the speed up also? Because now lot of code it writes, lot of cases it said that might not be relevant also. So in this case, how we can be fast pace plus quality assured.
Maybe I can give you my example. In my company as well, we are generate 60% of the code in few of the services. 80% of the code is now generated by the AI. And as I said, we are deploying twice a day. Honestly, with the AI generated code, security is the biggest issue. The copywriting, because it gets the code from all over. I'll tell you another interesting question. In the Docker images it builds, maybe it can take the base images of somebody random and it can ingest into your production. If that random guy has changed the code or the Docker images, push it to the public repository, then you are doomed, your production is gone. So it's not about stopping anybody or stopping at cost of the security, you stop anybody or slow down the CI/CD process. It's automation. The way you design the CI/CD pipeline, the more and more strengthening and bring the security also an integral part of the CI. And not just the CI, it should shift left, it should go with the developer as well. As in when they are writing code, the scanning should happen there, and then they will be pushing the code, and the CI have so many guardrails which will scan. So when you have everything and you give the early feedback, and believe me, there is again, people will be, there is no delay in the pipeline, because when I'm using a vulnerable image, in my ID itself, I'm getting that there is a vulnerability, I'll fix it, then I'll push it. In the push, again, the scanning will happen. Anyway, most of the vulnerability is anyway taken care of. And finally, it will go to the production. In the production system, I already have all the security component installed and the policies is there in the system. So even though somebody is doing wrong, it won't go anywhere, because I have designed the system such a way. So bring the automation, strengthen your security posture, and then allow developer to write the code with the AI. There won't be any problem, and you don't have to compromise with the speed as well. That's my example. Maybe people will be doing it even a different way, but actually our impact KRI or KPIs of the DevOps is faster feature development, so we don't compromise with that.
Thank you, Abhishek.
I hope I was able to answer your question.
Thank you, Abhishek. In the interest of time, if there are any follow-up questions, we can probably take offline. Really want to thank the panelists. Really amazing sort of hearing you today, and thanks for the engaging conversation.